You may remember from the film Gravity a portrayal of the threat that space debris poses on Earth-orbiting spacecraft. Travelling at over 25 times faster than a jet airliner, even a speck of space debris the size of a pea has the kinetic energy to punch through external surfaces, endangering multi-million-dollar spacecraft that provide services such as weather forecasting and navigation. International guidelines have been established to minimize the growth of future debris in orbit. One such guideline stipulates that the new spacecraft orbiting close to the Earth should come back down to burn up in the Earth's atmosphere within 25 years. This process is known as deorbiting and ensures that your spacecraft won't remain in space as debris, threatening other spacecraft for generations to come. Many spacecraft rely on air resistance as the primary or backup means of dissipating the mechanical energy of the spacecraft to bring it back down to Earth. That's right, even in low Earth orbit, there is an atmosphere billions of times thinner than what you breathe on the Earth that over a very long time can wash away a spacecraft's energy, just like air resistance slows down a cyclist on Earth. And when I say a long time, I mean it. At popular altitudes above 600 kilometers, it can easily take more than the recommended 25 years to deorbit using air resistance alone. This limits many spacecraft, particularly popular miniaturized spacecraft, to altitudes less than 600 kilometers, limiting their utility. And not only is the atmosphere thin in space, but due to the sun's radiation, also contains electrically charged ions and electrons known as the ionosphere. Recent research has identified a way to accelerate the deorbit of spacecraft to help deorbit a spacecraft within 25 years using a plentiful resource in space, electricity. Have you ever heard the saying that opposites attract? By electrically charging a spacecraft using onboard electrical power, it will attract ions and repel electrons via its electric field as it orbits through the ionosphere. By Newton's third law, for every action there is an equal and opposite reaction. The ions and electrons pull on the spacecraft as they are deflected by its electrical field, dissipating its energy to accelerate its deorbit. This phenomenon is known as ionospheric drag. In fact, at altitudes above 500 kilometers, the orbit decay power with ionospheric drag is an order of magnitude greater than the drag otherwise acting on the uncharged spacecraft. To put this into context, the research concluded that a spacecraft charged at minus 500 volts can deorbit from 800 kilometers altitude using ionospheric drag within 24 years. Whereas, the equivalent uncharged CubeSat would only complete 6% of its own deorbit in the same period of time. The research also found that ionospheric drag is stronger in direct sunlight compared to eclipse because the ionosphere is denser, meaning that there are more ions and electrons to slow the spacecraft down via electrostatic interactions. Ionospheric drag acting on electrically charged spacecraft is an example of emerging technology that will help keep space clean and debris-free for generations to come. If you'd like to know more about ionospheric drag, a link to the original research paper can be found in the video description. If you found this video interesting, please like and subscribe, and if you have any questions, leave a comment below.